Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about relativity space. So let's dive right into it. Now, what is the idea behind this company? Well, it's surprisingly simple, is that make a 3D printed rocket. Now, you may be familiar with the fact that many company at this point in time, from small startup to big as SpaceX, they are making what we call 3D printed engines. That's a normal thing at this point in time. That is like basic bitch stuff. However, what these companies trying to do not only is to make engines, but also to make the whole structure of the rocket, from tanks to pressure tanks to piping to vanes to support structure, everything. Basically, try to 3D print as much as possible. Complete rocket, of course, removing electronics obviously, but that's the whole point of it. So their idea is, at the end of the day, they want to achieve a status where they are like, okay, they have a 3D printer, all you have to give them is raw material. Tada, done, go home. And they have a goal for themselves where there's like, if we achieve this, we have succeeded our basically, it's like, if we get there, this is our end point. So their end point is like from matter to rocket in 60 days. So they will have a shipment of raw material, and they will have shipment of a completely built rocket in 60 days, 60 days. That's their end point, basically 2 months from start to finish. They can do this, and because it's completely 3D printed, even the structures, they can update the structures much more quickly than any other company, including SpaceX. And they started in 2015. Now you have to understand this, at this point in time, this company has many people from Blue Origin and SpaceX, and that does give them a bit of a clout, because even though they have not so far launched anything into space, when it comes to contracts, they are getting way too many contracts. You will be like, dude, how the heck you are getting Pentagon contracts? Like, that's a Department of Defense contract for which SpaceX had to actually sue them. Just like, bro, let us at least apply them for bidding for it. So reality is they do have some clout, so to say, and their tagline is very simple: design, print, fly. That's the whole point. It's like, if you want to change, do any modification into their system, let's say fairing modification or whatever have you, they can just do it. It's like, okay, mark 1, mark 2, mark 3, mark 4. It won't be like mark 5 they have finally built it and then they're gonna clone it. No, they can update every single time. It won't be an issue. That's the whole point. Design, print is just a 3D printed system, and fly, take it and go to orbit. So what tool they are developing for this? Well, this is the whole thing. Their whole selling point is that they, at this point in time, they have the world's largest metal 3D printer. There are many 3D printer in this world, and like the largest would be the 3D printer that is being used for making houses. So that works on concrete, but metal wise, they have the largest world record at this point in time. And everything about this 3D printer is custom built. Now, to give you a context of that, when they started the system, the printer used to catch fire every 5 minutes. So reality is like they have to learn everything from scratch. It's not a system where you if you look at the 3D printer used by many small startups and even SpaceX, you will notice that it looks like a complete product, because it is. There are many companies that are selling this sort of equipment outsourced. But for this kind of scale, where you are like, okay, we have multi-meter long structures, yeah, there is no company that is like, dude, that's even possible. So they took a gamble on themselves where they're like, no, we will build this goddamn printer. So that's the whole point. And metal deposition is that's how they're doing, but they have a rotating base, because most of the things they want to build, especially when it comes to rocket, is cylindrical in nature. So inherently they are just laying the material down there. Now at this point in time, aim of the system is like a core, like this printer, because their rocket is the easy part for them. Like, let me be very clear, rocket for them is just a CAD modeling for them, because you have a CAD, you put the file into the 3D printer and done. So making the 3D printer is their main part. Like, that's what they've been doing for past 5 years. And if their printer works to the extent they expecting it to, right now they are not there. Right now they are like, we can do it, we can 3D print, but it's not as like control P. It's not there yet. But if they achieve that, they can literally remove SpaceX from the map. So that's how powerful this technology would be if they figure it out. And because this is completely proprietary, heck, you will find like most of their photos, like end effectors are always blurred out. They're like, bro, that's our proprietary stuff. So if they can crack this puppy, they will be on the next level, because designing the rocket is super easy part. Making the rocket is the hard part, and therefore making for them is like, bruh, control P. So that is the whole point. This is the tool that they are developing. They are calling it Stargate at this point in time. So what are they developing, as in like that's tool, okay, but like what goes behind it intellectual property wise? So their intellectual property is the software that drives this kind of 3D printer. And another aspect you have to understand, because you are dealing with something this large, thermal expansion and contraction of the material would be a severe issue. So what does that mean? What does that translate to? That simply translated, they actually have a high level AI analyzing everything. Because if you do not have that, if you run on like presets or settings like that, it will simply not work. The metal tank tank will literally have cracks and gaps and all that jazz. So fundamentally speaking, they have to have an AI that's using vision, that is using X-ray, that is using thermal vision, whatever they can build, they have to utilize to actually analyze and compensate in real time. Otherwise, this printer simply will not work because of the size of it. So that's the whole point of it. Everything that goes into that printer, from the basically the hardware that they are building, from the software that drives that to firmware that controls it, all of them is their proprietary system. On top of that, they cannot just use any metal. They cannot be just like, hey, can you give me that metal alloy? Because it's 3D printer metal, they have to figure out custom alloy mix. Basically, metal is the same. It's like steel or aluminum or whatever have you, but how they are mixing it, that gives them their proprietary sauce, secret sauce. So based on that, they are achieving the results, because that was the first thing they realized. It's like, yeah, we cannot use a normal 3D printer basically cartridge for these puppies, because it will not work, because the expansion and contraction. So like, for same way how basically Elon Musk company Tesla, when they started to make that giant aluminum forge, they're like, yeah, most system will not work for this. Like, they have to develop a custom alloy just so they can use that giant giga press. So same goes here. Like, just to utilize the printer, they need to use a custom ink. And their PR department is surprisingly amazing. I have provided a video down below. While their YouTube channel does not have a lot of what you call views or subscriber, but it's like goddamn amazing videos. It's like, dude, it's like iPhone launch kind of thing. It's like, this is the rocket, this is like animations good. So their intellectual property is serious. That's why like so many companies are putting some serious amount of trust into them. So how they're gonna start? Well, their start is Terran 1, which is supposed to be launched basically before 2021 is out, and it is use and throw. Now you may be like, why the heck in modern time you are making use and throw? Well, the reality is very simple, because this rocket is like a medium lift kind of system, 1.2 tons for $12 million. So that is expensive than basically Electron rocket, but more capable than, but it's cheaper than Falcon 9, and lighter than Falcon 9. So it's literally between Electron and Falcon 9. And the idea is, if they can achieve their end goal is cheap and easy to make. If they can achieve this point, the recovery would be a bad idea, because like recovering the damn thing takes time. Like, that's the same reason why SpaceX, they had boats for recovering the fairings, and they're like, dude, that boat was costing more than the fairing was worth. Like, yeah, just let it land on the sea, it's good enough, just bypass the shit. So that's the whole point. If they can make this in 60 days, if they can achieve the cost they are aiming to achieve, it literally would be wasteful for them to like have system for recovery systems. And you may be like, okay, isn't Electron also started like this, where they're like, we're gonna be completely cheap, we're not gonna reuse, and now they are trying to do reuse through parachute? Well, they are utilizing carbon fiber, which is expensive, and on top of that, you have to make carbon fiber. Manufacturing carbon fiber structures is idiotically expensive. It's like idiotically expensive. So that's the whole difference here. For them, it's just a raw powder. For Electron rocket, like, no, dude, we had the raw material, and then we spooled it up, then we baked it, and we did all the jazz with it. That's why it's so expensive. For them, it won't be. So again, that's their aim. And after that, they're gonna do something future. Basically, they are trying to build a better Falcon 9. Now you have to understand, Falcon 9 at this point in time is the most advanced rocket system out there. Now it's not the best because it's the best, it's best because every goddamn else rocket is stuck in 1970s. That's the whole point. That's the whole reality of it. It's like literally every other country is like, 1970, that was good time, Cold War, everybody was pouring money into it like there is no tomorrow. The moment that money train stopped, people even stopped researching. It's like, yeah, just like, just you have a weak rocket. What if we put 5-6 solid booster on it? It's like, why? But you get the point. So if you want to beat Falcon 9, it's surprisingly easy to do, because you have to understand, Falcon 9 was built in a time when SpaceX was not a big name. They did not have GG amounts of money. You can see that like Falcon 9 basically in early variants, they were utilizing aluminum grid fins, which used to melt off. Like, I'm not kidding, like literally like, yep, chunks flying off. So now they have to use titanium. They could not have afforded titanium back then. Now they can. So there are many compromises like that, like in this whole system, where you're like, if you have to start from scratch, okay, let's build something like Falcon 9, let's do it better. Can you do that? Absolutely. There were hundreds of faults with that system. So if you want to build a better Falcon 9 system, you can. Now you may be like, this looks like Starship ripoff. Well, you have to understand one problem with Starship. While Starship would be awesome, only SpaceX will be able to use it. What does that mean? That simply means it would be too goddamn big. It's like trying to use a 18-wheeler truck for a pizza delivery. That's the whole reality of it. Like, it has the capacity of upwards of 100 tons. To give you a context of that, modules of ISS are less than 30 tons. So let that sink in. So that's why Falcon 9 is that sweet spot. So they're aiming for that. Now, because they are like, Gen 2, it's completely reusable, even the second stage. Now, they're gonna do 20 tons to low Earth orbit. 22 tons is pushing it much, but like 20 tons is like more than good enough, and it will be cheaper and better. Now, how they are achieving this? Well, first 3D printer, so they can do every model would be an iteration, and they are utilizing high level AI for inspired by nature design, so to say. So, what does that mean? That simply means the structures, like when you see Starship, there are welding support structures. Now, again, those support structure are like, a compromise between how much weight you want to add, how much strength you want to add. Now, what they are doing, because they can 3D print, is they are 3D printing a lattice inside it. Like if it looks like a substructure of a leaf, because it's inspired from that. Benefit of that is like this will have the least amount of material and most amount of strength. So strength to weight ratio would be god tier level. So, and it can only be achieved if you are utilizing something like this, so like a 3D printer. So they are banking on that core system where they can have like improvement as high as like 20%. They're like, no, any other manufacturing system will be 20% heavier. Now, if you can make a rocket 20% lighter while still maintaining the structural integrity and does not require like, magical giant press or like, magical metal alloys, that would be amazing. So that's the whole point of it, and they are aiming for 2024. Now, can they pull it off? That all depends on their printer. That's why I specified a rocket part is basic bitch for them. If they can pull off the printer part, everything else after that is super easy. That's why I'm saying, like, if they can crack the printer part properly, they can remove every other space company from the map, so to say. So this was my presentation on this new company that is trying to 3D print everything. Now, hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.